Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we're going to be looking at previous year questions of physics asked in medical and engineering entrance exams in India. Today we're dealing with a very important chapter. The name of this chapter is Description of Motion in 2 and 3 Dimensions. Now this topic, it discusses the same topics, the same ideas as discussed in the chapter Motion in a Plane, which we know is the fourth chapter in the grade 11 syllabus for physics in CBSE. So in this topic there are some questions, and today we're going to be looking at a select few of them. So without further ado, let's start with the first question. Two forces are such that the sum of their magnitudes is 18 newtons and their resultant is 12 newton. The resultant is perpendicular to the smaller force. Then the magnitudes of the forces are A 12.6, B 13.5, C 10.8, D 16.2. So how do we solve this question? Well, in order to solve this question, we need to draw a vector diagram. So from, say, a point O, you have a vector P going in this direction, and a vector Q which is at an angle theta with P, and then you will have a perpendicular vector to Q which is R. So the resultant vector here is perpendicular to vector Q, and then from this you can form a parallelogram like so. So now you have a parallelogram diagram for the given vector arrangement. So over here we'll consider Q as the smaller force. So these vectors are force vectors, so if we consider vector Q as smaller, then it contains smaller force. Now in the question it is given that the resultant R is 12 newtons and the sum of the magnitudes of the two forces is equal to 18 newton. So now if you look at this diagram, you see that vector Q and vector R are perpendicular to each other, so therefore OQR forms a right angled triangle. So when you look at that, according to Pythagoras theorem, Q square plus R square will be equal to P square. Now how is it equal to P square? Because in a parallelogram the opposite sides are equal. So in this parallelogram, OP is equal to QR, so therefore vector P, the value of QR will also be the magnitude of vector P. So Q square plus R square gives you P square according to the Pythagoras theorem. Now you can write this down as P square minus Q square on the left hand side, and on the right hand side the resultant squared, that is R squared. So P square minus Q square can be written using algebraic identities as P plus Q times P minus Q, and then the resultant will be R square. Now remember, the resultant's value, the magnitude of the resultant is given as 12, so you can apply that value here. And then we also know the value of the sum of the magnitudes, that is P plus Q. So P plus Q is equal to 18. So 18 times P minus Q gives you 12 square. 12 times 12 is 144. So therefore the value of P minus Q will be 144 divided by 18. So you know 8 times 8 is 64, so we'll just multiply 18 times 8. So 8 times 8 is 64, 6 goes there, 1 times 8 is 8, 8 plus 6 is 14. So therefore the value of P minus Q is equal to 8. So we now know P plus Q is equal to 18, p minus q as equal to 8. So on addition, you get 2p on the left hand side, on the right hand side it's 26. So therefore p will be equal to 13. The magnitude of vector p is 13. So since p minus q is 8, you can write 13 minus q equals 8. So therefore q equals 13 minus 8, which is equal to 5. So you have the magnitude of vector p as 13, the magnitude of vector q as 5. So if you look at our following options, you can see that option B is the correct answer to this question. So for getting this, we just use the parallelogram law of vector addition, and we found out the value of both, the magnitude of both the forces. That is the correct answer. Option B is the correct answer for this question asked in 2002. Now let's look at the next question. A boy is playing on the roof of a 10-meter high building. He throws a ball with a speed of 10 meters per second, and he throws it at an angle of 30 degrees with the horizontal. You need to find out how far from the throwing point will the ball be at the height of 10 meters from the ground. So how do we solve this question? Let's first understand it with a diagram. So this is a building which is, say, 10 meters high, and from here a ball is being thrown, and it is thrown with a speed of 10 meters per second, and then it undergoes projectile motion. Now let's consider this to be the end point of the projectile motion. Now what it says is that the end point of the projectile motion is also at 10 meters from the ground. So even if you were to throw this from the ground as well, it would still be the same, so there will be no difference. So we also know the angle at which this projectile was projected. The angle here is given as 30 degrees. We also know the value of g, sine theta, as well as cos theta. So now, how do we solve this question? To solve this question, the question is asking us how far from the throwing point will the ball be present. So basically, they're asking us about the quantity known as horizontal range. So how do you find the horizontal range r of a projectile in projectile motion? So r will be given as u squared times sine of 2 theta divided by g. So let's apply the formula. So r will be equal to 10 squared times sine 60 divided by g, which is 10. So we have 10 times sine 60, that is root 3 by 2. So it becomes 5 root 3. So you have 5 times 1.732. So we just multiply 1732 by 5. 2 5s are 10. 3 5s are 15, plus 1 16. 7 5s are 35, plus 1 gives you 36. And 1 5s are 5. 5 plus 3 is 8. Add the correct decimal and you get the value of horizontal range as 8.66 meters. So the horizontal range that is traveled by the projectile in this scenario is option D, 8.66 meters. That is the correct option for this question asked in 2003. Now, let's look at this question. Now, this is a very interesting question. The coordinates of a moving particle at any time t are given by x equals alpha t cubed and y equals beta t cubed. The speed of the particle at time t is given by one of the 4 formulae here. Which of these formulae is correct? So, how do you solve this question? We have x equals alpha t cubed. Velocity in terms of x can be found out as dx by dt. So that is alpha times 3t squared, which is 3 alpha t squared. Similarly, the velocity along the y component is dy by dt. That is equal to alpha times, not alpha, which is beta times 3t squared, because d by dt of t cubed will be actually 3t squared. That is standard differentiation. So you will get 3 beta t squared as the value of the y component of the velocity. So now we know the x component and the y component of the velocity. So in order to find out the actual velocity, we can write the square of the actual velocity as the sum of the squares of vx and vy. So v squared will be equal to vx squared plus vy squared. So let's plug in the values of vx squared and vy squared. So over here it will be 3 alpha t squared plus 3 beta t squared. So we can, it's actually 3 alpha t squared the whole squared and 3 beta t squared the whole squared, because in our calculations we took vx as 3 alpha t squared. So if you were to square that, you have to square the entire thing. So you have 9 alpha squared t raised to 4 plus 9 beta squared 3 t raised to 4. You can take 9 t raised to 4 common. You will get alpha squared plus beta squared as the correct answer. Alpha squared plus beta squared. So therefore you can take the square root of this given expression. So you'll get v on the left hand side, that's the velocity, and on the right hand side 9t raised to 4 becomes 3t squared, because that is a perfect square, and you have alpha squared plus beta squared that can be taken under a square root. So if you were to look at our following options, you can see that option B is the correct option to this question asked in 2003. So first we are given the distances with respect to time. So we will take their first derivative to find the velocity component along x and y axis, and then just add the squares to get the squared value of the total velocity, and then take the square root to get the speed of the particle at time t. Moving on, if vector A cross vector B is given as equal to vector B cross vector A, then find the value of the angle between A and B. So cross product is usually not commutative. That means A cross B is usually not equal to B cross A. It only happens in special conditions. We need to find out the special condition for that. So if A cross B is equal to B cross A, then you need to find the angle between A and B. So A cross B equals B cross A. So we can take the modulus on both sides. So modulus of A cross B equals modulus of B cross A. And now we can write modulus of A cross B as AB sine theta times n cap. On the right hand side it will be AB sine theta, sine of minus theta times n cap. So since A cross B is usually minus of B cross A, so therefore the value of theta will be negative in this case. So n cap gets cancelled, AB gets cancelled, so you basically have sine theta as equal to sine of minus theta. So sine of minus theta can be written down as minus of sine theta. So sine theta is equal to minus sine theta. So therefore 2 sine theta equals 0. That means sine theta equals 0. That means you will get theta equals 0, pi, 2 pi, etc. So basically the condition is 2n pi. So if you were to look at the given options, you can see that option A is the closest answer to the value of theta. So the angle between A and B, if A cross B equals B cross A, is option A, pi. So pi is the correct answer to this question asked in 2004. Let's look at the final question of this episode. A projectile can have the same range r for two angles of projection. If t1 and t2 be the time of flights in the two cases, then find the product of the two times of flights being proportional to. So basically you need to find out t1 times t2, and then you need to find out to which of these four options is it directly proportional to. So how do we solve this question? So here it said that the projectile has the same range r for two angles of projection. So this is actually a very special case. So range for two angles of projection is same for angles that are complementary. So for two complementary angles, the range will be exactly the same. So now we will consider t1 as equal to 2u sine theta by g. Then we can write t2 as equal to 2u times sine of 90 minus theta divided by g. So when we can take the products, t1 times t2 on the left hand side. On the right hand side it is 2u times 2u, that is 4u squared. You have sine theta from t1. You have sine of 90 minus theta, that is cos theta from t2, divided by the denominator being g squared. So over here you can write 2u squared times 2 sine theta cos theta divided by g squared. So 2 sine theta cos theta gives you sine 2 theta. So therefore you can write 2 times u square sine 2 theta, and then you can write g on one side and g on the other side. So basically you get t1 times t2 as equal to 2 by g into the horizontal range, which in this case is same for both the angles. So t1 times t2 is equal to 2r by g, so therefore t1 multiplied by t2 is proportional to the range itself. So if you were to look at the given options, you can see that option C, r, is the correct option. So basically you take the special condition where the range is same, that is theta and 90 minus theta. So you find the time of flight for both cases. So since one of those is 90 minus theta, it becomes cos theta. And then we use trigonometric identities and then rearrange the equation in order to get the right hand side in terms of range. So therefore you can get the value, you can get the relation t1 t2 is proportional to r, which makes option C, r, the correct option for this question asked in 2004. So that concludes this episode of NEET JEE Main. We hope you found this episode interesting. For more useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. You can also hit the notifications button beneath the video to get the latest updates from our channel. In order to watch more of our videos on NEET JEE Main for physics, you can just hit the link in the description down below. So that's it, guys. Until the next webisode, take care, stay safe, bye-bye for now.